Hi guys, welcome back, and today we are going to be going over one more super challenging measurement problem that involves mass. It's actually pretty straightforward, but a lot of people get a little confused with the wording of the question, so here we go. Orange juice is poured into a glass that has a leak. The mass of the juice as a function of time is m equals 6t to the power of 0.9 minus 2t plus 10, where t is greater than or equal to 0. M over here is in grams, and t over here is in seconds. So let's just focus on A right now. At what time is the water's mass the greatest? I think that's supposed to say orange juice, but it's okay. So we know what the time where the water's mass is the greatest. That means this equation is maximized. So a way that we can do that, which you've probably encountered in your pre-calculus or calculus class, is by taking the derivative of the above equation with reference to time. This, when put equal to 0, will give us the critical points of the equation itself, and then that will help us find the maximum point. So dm dt will equal to, I'm just using the power rule right now, 6 times 0.9 times t to the power of 0.9 minus 1 minus 2. And this will be equal to 0. Further simplifying this, we have 2 equals 6 times 0.9, which is 5.4, t to the power of negative 0.1. Okay, so we can also rewrite this as 5.4 over t to the power of 0.1 equals 2. Simplifying this further, I'm just going to bring this up and divide it over here. 5.4 divided by 2 is 2.7, which equals 1 over t to the power of 0.1. So I'm going to flip this around one more time. So I'm going to draw a little arrow so you can follow what I'm doing here. Okay, so moving t to the 0.1 over here, 2.7. So now I'm just going to solve for t over here, and that should give us about 589.113 seconds. Okay, so this is our time. It's what time the water's mass is the greatest. So part B next asks for what is the greatest mass. Since we already have the time where the water's mass is the greatest, we can just plug it into this equation over here to get the amount of grams where the mass is the greatest. So plugging it in, we have 6 times 20,589.113, all to the power of 0.9. Let's put parentheses around that. Minus 2 times 20,589.113 plus 10. I'm just going to plug it into my calculator over here. Three to the power of 0.9 minus 2 times 20,589.113 plus 10, and that should give us 4,585.36 grams. Okay, so we have this in grams, but we also, I think we should change it to kilograms, because since that is a base unit, you can check more about base units in my previous video. So changing this into kilograms, we want kilograms at the top. So we know that 1 kilogram equals to 1,000 grams. So we would have to divide this by 1,000 in order to get the amount of kilograms. So dividing it by 1,000 on my calculator, I get 4.58 585, whoops, let me write this again, 4.585 kilograms. And this will be my final answer. Okay, I'm going to do part C on a different piece of paper. So what they're asking is that what is the rate the mass is changing at t equals 2 seconds? The rate that the mass is changing is also known as dm dt. And lucky us, we solved this right here, the equation for dm dt. So I'm just going to copy this over. So we know that dm dt equals 6 times 0.9 times t to the power of negative 0.1 minus 2. Okay, so to solve for t equals 2 seconds, I'm just going to plug t into the equation. So rewriting this would be, and let me just plug this into my calculator. That would give us 3.038. So this is dm dt, and m is in kilograms, and t is in seconds. So that means our answer will be in kilograms per second. Looking at number D, oh yeah, by the way, this is our final answer. Looking at part D, at t equals 5 seconds, we are going to repeat the same thing that we did earlier in this problem and just plug in 5 to the given equation for dm dt that we solved for earlier. So that will give us dm dt equals 6 times 0.9 times 5 to the power of negative 0.1 minus 2. Plugging this into my calculator, I can see that this equation equals to 2.597 approximately. And again, I'm going to use the same units, kilograms per second. This is our final answer. I hope you learn a little more about dimensional analysis and measurements and how to change between mass functions and how to deal with mass as it changes as a function of time. Thank you for watching.